नहीं है, right? Okay. As far as we know that continental drift theory has lot of loopholes, right? That's what when you talk about critically analyze, so especially the forces and the assumptions he has given, even the evidences he suggested can be criticized. So the fundamental flaw of when you write about critical analysis of continental drift theory, what should be the beginning point?
First, can we start with Snyder's theory, like basic intro of Snyder? What he said and what Taylor said in one line.
No, that shouldn't be a good beginning, especially when you are going to critically analyze. Right. Discuss continental drift theory presented by Wegener will be a different answer. When critically analyze continental drift theory will be a different answer. When you are critically analyzing, that means you are analyzing both pros and cons. Discuss continental drift theory, you are only supposed to discuss them, whatever Wegener has suggested. In between, a little bit of criticism is okay. But when critically analysis, you have to give both pros and cons. What he is good for, what he is not accepted for. So when it is about critical analysis, you can start there may be, once we discuss other theories also, in comparative analysis will be a different answer. Here, critically analysis, the most fundamental criticism of Wegener theory is associated the forces he suggested, right, has been very heavily criticized at that time also. That it's not possible that, like Jeffrey has suggested, that if the moon has so much power, it will stop the rotation of the earth itself, right? So that was criticized at that time only. So you can start with like any theory which is there. So you should start with the importance of the theory or the importance of the topic. So you can lay down that continental drift theory is one of the earliest which tried to explain not only the mechanism of the landform but also the distribution of continents in the ocean, which ultimately culminated into plate tectonic theory. Right. So that introduction would be better. Even after that, if you want to write about the historical perspective, you can give them. But
I know the drifting of continent was considered as a mystery until 1858, and Antonio Snyder suggested an integrated model of all continents joined together.
So drifting of continent was not a mystery because nobody knew that continents are drifting. That itself was assumption, right? It was not mysterious, but there are a lot of mysteries, like especially like for example the paleoclimatic studies have come out with a lot of complex and mysterious information which forced many scientists and geographers to think about their aberrations in their distribution. So that was a mystery, that was complex. That's what led to the foundation of the plate tectonic theory or the continental drift theory. But continental drift theory was not mysterious. Because the thing which is
answer being a very general approach, then being concise with what about we talking, and then the end note is what exactly what. That's how an answer should be starting.
no. Look at here. An answer of graduation style is different. An answer for UPSC is different. UPSC expects you to use your knowledge to reflect your creativity, right? Rather than simple writing of information or vomiting of information is graduation or degrees exams, college exams. So that is how the college going students are different from civil servants, where you want to reflect your creativity, right? Details is available on keynoteis.com पे जो एक वीडियो है मेरा, उस पे पूरा डिटेल है. Just in a brief, so that because we will keep on writing answer in the class also. So first is the intro part, right? Then you have body parts. Then you have conclusion part, right? How intro and conclusion is different as compared to the college going. If your intro is very, very good, your body part will have automatic flow, right? And that is of very high importance in civil services writing. Roughly the word limit should be 10%, 80% and 10%. It shouldn't be very lopsided. For example, you can't go for almost 1 page introduction in a 2-page answer. If the answer is 2 page, hardly 1/4 of a page should be devoted to, even less than that, to conclusion and introduction. Right. Now, how to introduce it? Generally, the way we have been introducing in the normally, like for example, most of our college fellows will be introducing questions as per just the name it. Let's say, for example, if you are writing about the empowerment of women in India, like let's say essay, if you are writing, what should be the beginning? For the introduction of essay, you have an immense amount of scope. For introduction of a 250-word answer, the introduction will be different. For an introduction of 150-word, the introduction will be different. Right. So when you go for introduction, especially in an optional paper, in any paper there are three components of introduction. The topic is what is it. Right. The second is the importance of the topic. In a nutshell, why should we study it? Why should we study the topic? Right. So when you highlight importance, there are two ways to highlight the importance. First, importance of the topic with respect to humans, and the importance of the topic with respect to the subject matter. Right. Why should we study continental drift theory as an IS officer? What is continental drift theory is the first part. So when we say what is the topic, here comes the definition of the topic. That is the traditional beginning. You define the topic, you introduce your answer. That's the oldest possible beginning whenever you have been writing in your college days and school days. But for civil services writing, the beginning here is very, very important. If you start with the beginning, unless until the definition itself is very complex, you can go with a definition which you feel that yes, definition will add some value to your answer. Then you can define. Right. For example, even continental drift theory, the definition can be slightly better. When we are talking about the continental drift theory, is a theory related which explains about the drifting or slow movement of continent. Right. So that is okay, but there will be many topics where definition will not be at all important. So there you can start with, or you can club entire in the initial lines. What do you mean by definition of the topic? Importance of the topic with respect to humans, whether it is directly or indirectly. Let's say suppose continental drift theory. So how continental drift theory is important? Why should we study? Exactly, which has formed the foundation for the origin of the theory of plate tectonic, and which has simplified a complex subject like geography and has evolved to explain almost all the landforms very scientifically and reasonably. That's the importance of the continental drift theory. Right? We have talked about not only about humans but also subject. Right? Continental drift theory is important because it has helped found the theory of plate tectonic, which forms the base of geomorphology, heart and soul of geomorphology. Had continental drift theory been not there, perhaps even plate tectonic wouldn't have been there. Getting that point? So obviously that is the importance. Because look at here, this topic is redundant. Continental drift theory is no more valid in any aspect except the fact that continents are drifting, but even presently what we are accepting, it is not exactly what Wegener has suggested. Yet it is mentioned in the topic that suggests the importance of the topic. Only to give some credit to Wegener, that thank you for initiating that. Thank you for your beginning of the thought. Thanks for bringing the idea on the forefront. Only then later on, scientists have started discussing, explaining, talking about it. If you wouldn't have started, this plate tectonic theory wouldn't have been there. That's why this topic is mentioned. Otherwise, this topic has no value in the present day scenario. Yet it is mentioned in the syllabus, not only in the geography syllabus, but also in the civil services. Highlight that. Tell the examiner that I do understand the importance of the figure or the data you are presenting. Right? So when we talk about humans, that is basic perspective with respect to direct or for example, earthquake. Earthquake is a disaster. For example, floods and droughts. So floods and droughts are also disaster faced by humanity. For example, empowerment of women. So empowerment of women is an integral part of a civilized society where 50% of our population, if not empowered, we cannot be called civilized or growing up or a developed nation. Right? So understanding the empowerment of women helps you understand the civilizational attainment of a society. Because if woman is not empowered, like for example, essay में अगर लिख रहे हो आप, तो answer of the essay or the beginning of the essay will be different. Right? In the land of Durga, Kali and Saraswati, we are talking about empowerment of women. It is a shame on us. Isn't it? The moment we talk about empowerment, means it is a negative connotation. Isn't it? Empowerment का मतलब क्या? That means they are not empowered. That's why we want to empower them. And women as a part of our life, whether it is in a male chauvinist society, is a male centric society, if you are talking about empowerment of women, that means something is wrong with us. In a country like India, where the Rigvedic period talks about participation of women in sabhas and samitis, and they have almost equal right. So historical perspective, you can go there, right? Then you, even after that fact, like for example, the most civilized and advanced country like US is still struggling to find out her first woman president, and we have already have it long back. Razia Sultan was there in the medieval period also. Good number of women can be given example in the ancient period also. Then in the freedom struggle you can talk about. Then in the post-independent India, the most powerful prime minister of the country, you can say till date, it was the Indira Gandhi. And still we are struggling for the to give women its due place. वहाँ से शुरू कर सकते हैं. Instead of defining empowerment, what is empowerment and all, you can define in the way when you talk about body parts. So, and body parts is basically should always flow from the question. Like, for example, critically analyze continental drift theory. So, the answer should always be flowing from question. The direction should be unidirectional, nothing else. Like you will have terms, generally keywords. Keep on playing with those keywords. Critically analyze continental drift theory. So, keyword is what? Continental drift theory, and one supplement is critically analyze. Right? How plate tectonic theory is an improvement over continental drift theory. So, there are two keywords. So, keep on playing with those keywords. Continental drift theory, critically analyze. Continental drift theory, critically analyze. In this question which we have discussed last time, or which I have given you last time, that is critically analyze continental drift theory. So, there is a single keyword, but the loop is critically analyze. So, talk about continental drift theory and keep on analyzing it. Right? Talk about the general belief of Wegener that he propounded an idea and he suggested that the continents are drifting. This is his idea. Now, continental drift theory, part of continent, now critically analyze. Critically analyze, continents are, even the present belief, with the help of the plate tectonic theory, yes, continents are drifting, but not in the manner Wegener has suggested. Critically analyze. You are talking about the drifting of the continents in a larger context, you are proving it, that yes, continents are drifting, but not the way. That's what critically analyze. You are analyzing critically, both pros and cons. We are talking about, yes, continents are drifting. Even the present day, the most scientific theory of plate tectonic has proved that continents are drifting, continents are moving, but not in the manner Wegener might have suggested or might have thought. Right? Then come to that evidence he suggested. Write all those evidence, critically analyze. How will you critically analyze? When you talk about the when you talk about the evidences, let's say for example geographical similarity. Yes, that is one of the bases, and still it can be visible, but that mere assumptions cannot be the basis for such a big idea. So at that time it was not believed, not accepted, heavily criticized. But the evidences he suggested proves that he was very confident of the fact that continents were drifting. Right? Then comes to forces. Explain the forces, explain his theory. Start with that he suggested that there existed a supercontinent till Carboniferous period he called Pangaea and surrounded by this. Come back to criticize. Next, change your paragraph and talk about criticism. That he suggested the existence of continent till Carboniferous period. But he didn't explain why till Carboniferous period. What has happened before Carboniferous period? Why did he choose Carboniferous period as the last entry of the existence of a supercontinent? That is critically analysis. Then you talk about forces, then you critically analyze the forces. First you write the theory, what he has suggested. According to Wegener, this is the forces. Then talk about that moon can't have that much, and a small difference of half a kilometer or few kilometers between the continents and oceans cannot generate a difference of gravitational force which will allow the continents to move freely over the symmetric against the rotational direction. So that was very unscientific. He himself is contradicting the way he suggested that initially he took the help of Suez, that Sial is moving smoothly over Sima. Then while explaining the presence of Rockies and Andes, he started talking about the resistance. And even if that resistance, the way we have criticized it. So you can, theory, criticism. Theory, part of theory, criticism.
So, writing in pointers,
That's fine.
it's fine. Yeah?
That's very fine. Like this, but there shouldn't be rigidity about it. That's the fundamentals of intellectuals, you see. You have to reflect yourself far above than the ordinary people, ordinary college going student. For example, if you have some criticism about me, let's say suppose if you are saying that any part of my teaching method is not very good or up to the mark, what should be my response? If I start reacting very badly, that means I don't have confidence in me. If I start explaining you, okay, this is how I thought, but since you are saying, I will consider upon it. And if I think that yes, your suggestion is genuine, I adopt it, that means it's not your credit, it's my credit. That I take the suggestion of a student at the highest possible, because ultimately if I am teaching for you people. And if you are not getting, so that maturity must be reflected there. So there shouldn't be any rigidity about it, that I'll be going for point wise, I'll be going for paragraphing only. Whenever you feel, it is you who has to decide that this particular information can be explained in a better manner in paragraph. Go for paragraphing. Paragraphing come point wise. Whenever you think that you have huge amount of information, yet you cannot place in the limited number of words, you choose point wise. But never be rigid. The pointers cannot be the beginning, unless until the question is very straight. For example, if the question is, what are the limitations of the continental drift theory? Following are the limitations of the continental theory. No, you don't need to introduce that question. If the question is very straight, but nowadays if you see, the question will be a statement, discuss, critically analyze, elaborate, elucidate, why do you think about it, do you agree? So that becomes very subjective in nature. Even in general studies also, the pattern will be similar. So there, if you want to introduce, that should be a qualitative introduction. Yeah, and you have enough amount, unless until the question is very straightforward. What are the different type of boundaries, plate boundaries? Suppose plate tectonics की हम अगर बात करें तो, following are the different types. But discuss the types of boundaries and the consequences of it as suggested by plate tectonic theory. Then the word discuss gives you enough amount of scope to become subjective. Yes, you can't directly begin that following are the types. Getting my point? I take a very simple question while explaining this, the difference between what is your name and introduce yourself. What is your name? You don't have any scope to write except that my name is Shamim Anwar, finish. You don't have any scope to explain your dada wanted this, your grandfather wanted this, your father wanted this, your mother wanted this. Since your mother is more important in the family decision making, that's why my name is this. No. Discuss the history of your name. You have all amount of scope. Discuss your name. The question is different than what is your name. Analyze your name. So you have enough amount of scope that someone of my name has ruled Greek Empire, and someone of my name is similar to my name, and the meaning of my name has ruled in the medieval period in Russian Empire and all. The one of the Khilji ones was the dynasty was this. Ashoka was a great king. My name is Ashoka. So that way, when it is the subjective, the statement itself becomes subjective. It gives you enough amount of scope. And 99% of the present day questions of civil services will be of that nature. So don't be rigid. You have to be flexible. That's the fundamental basic requirement of a civil servant, or for that matter any intellectual discourse. If we are having some discussion over a subjective issue, you just can't demean me by saying no, I don't agree. Yes, you have every right not to be agree, right? But you can't stop me from speaking, neither I can stop you from speaking on a subjective issue. Getting my point? That's the fundamental difference between a chai dhaba and a civil services factory, right? Wherever you discuss, you should reflect your maturity. So first thing is that avoid rigidity. Don't stop your mind as far as thinking is concerned, creativity is concerned. Then conclusion. Conclusion exactly opposite of the introduction. In the introduction we have talked about importance of topic with respect to humans. Here, impact of human over the topic. If you take several questions, most of the impact of human will be negative in nature over the topic. But there will be positive, which will be rare. Right? If the impact is positive, no issue. You just end with that. For example, continental drift theory. What is the impact of humans over the topic? Huh? That is evolution of plate tectonic theory. We used continental drift theory as the base, and we evolved a theory called plate tectonics. Right? So in that case, if you talk about, then plate tectonic theory becomes a positive impact of human, highlight that. And plate tectonic theory, importance of that. Now, if the impact is negative, then obviously something must have been done for it. Highlight that. What has been done? That means what has been done on the individual basis, on community basis, on institutional basis. Depending on the topic. If the topic is generally of international importance, you talk about what UN has taken steps, what the international community has taken steps, what is the level of international cooperation on that particular topic. If it is about the national level, then talk about the national steps or the government steps taken for that. Right? For example, if you are writing about command area development program or irrigation projects, so irrigation do have some negative impact. Like for example, heavy irrigation in Punjab and Haryana has led to deterioration of soil quality and the fertility of the soil. Highlight that. What steps has been taken by the government? Obviously, the rational use of water, a lot of research work, explanation, increasing awareness. What needs to be done? Your suggestion. Here, like for example, irrigation example, integrated water development program has been carried out by the government, but the awareness of the farmers, the research work should be done for each type of soil where the utility of water can be at the best possible level. You talk about the scientific method of irrigation. With this, the impact can be minimized or eliminated. Finish it. Always end with a positive note. Always. Howsoever pathetic topic you have chosen, the end line must reflect the optimism in you, that you are very optimistic. As an IS officer, you will be supposed to behave like an optimist. Even if you are posted, let's say suppose you are posted in a tribal district, right? And you know that you will be staying here for, let's say, 2 years. And you know that whatever steps you have taken may not bring any change on the ground level. You might have established a school, but with your 2 years effort, you can at the best can reach out to the people and try to convince them to send their children, yet they are not ready. And you may not be able to get even a single child enrolled in your school. Yet you are supposed to work there so that the next DM who comes, at least the groundwork has been done. You can brief the next predecessor and tell him or her that fine, this is the level of work I have done, and I hope if you continue with that, hopefully within a year or so, some children will start coming. And the moment we have the beginning, then there will be a lot who will follow that. So that optimism must be reflected in your answer in the ending line, even if it is the worst possible topic in the present scenario you can see. Hope you are getting my point. Let's say suppose you are talking about any of the economic issue. Like for example, some of the projects which we are carrying out as an institution, as a nation, and that is producing the worst possible result. Yet you are not supposed to be negative about it, at least in the ending line. Criticize, talk about that everything, but in a diplomatic, mature manner. Even if you want to criticize, there is a misconception that entering into the part of the government, you cannot criticize. It's not like that. You can criticize, but your criticism just should be with reverence. Just should be just like even we have every right, at least, and we do criticize our parents also. Very often, that shows the liberal attitude of the parents. If the credit goes to the parents, that they have made you, they have enabled you, and they give you that much space to criticize them. Right? But you cannot forget that they are your parents while criticizing. Remember that line and criticize the government. Yes, very healthy criticism, constructive criticism, mature criticism. Your language, your word, your way of writing must reflect your maturity. Yeah?
So there should be, like if you are criticizing, then there should be possible solution also in the answer.
Yeah, that's the end point. That's the end point. When you have talking what needs to be done is your suggestion. And the suggestion may not necessarily be purely yours. Whatever you have read in different quarters, different books, different sources, you can just apply that. If nothing is there, people's participation, the awareness, increasing awareness among the masses, greater cooperation among different institutions, international, national level, transfer of technology, these are very common terms to suggest, depending upon the nature of the question. End with a line that with these steps, since I am suggesting, so once these suggestions are taken up, things will be the best. So that way, ending line must be a positive note, reflecting your optimism, that you are an optimistic person. One of the most important quality of a leader. So be careful. Initially, don't take too much pain as far as the word limit is concerned. Don't take too much pain as far as the relevancy of concern in the initial notes. Just apply your mind. Be as much creative as possible. Write whatever you want without thinking, just like a child who has started learning to walk. You cannot blame that your knee is not very straight. When you walk, you should be straight. You can't. let him crawl or her crawl, let him do whatever they want. And that ways you should start. Treat yourself as a child as far as the writer of civil services answer is concerned. Then gradually evolve, and evolve obviously with a very articulated and integrated manner. Try to bring different ideas. Try to apply climatology into geomorphology, geomorphology into oceanography, oceanography into economic geography. Try to bring history into geography. Try to bring sociology into geography, and vice versa. When you are writing about landforms, try to write about the impact of landforms on settlement, human occupation, mineral resources in the beginning, importance of landforms. Try to, if you are writing about slope, talk about the importance of slope in human day-to-day life. Slope is one of the most important factor, physical factor affecting human lives. Slope determines the type agricultural activities, the types of crops to be grown, the types of settlements to be present in that area. Highlight that. If you are talking about temperature, talk about the fact that temperature is the most important climatic element which affects the humans, not only the various economic activities, but also even the dressing and dance pattern and various cultural aspects. Start with that. That means you are being beyond book. You are thinking beyond the factual information. You are thinking beyond whatever has been taught to you. And the moment you are reflecting those things, your answer will be different. Right? Now, in continuation of plate tectonic theory, continental drift theory, there is a theory called convection current theory of Arthur Holmes. He was perhaps the earliest supporter of continental drift theory. And when he started suggesting, he did believe that the explanation on the forces suggested by Wegener was not up to the mark and has very poor scientific basis. So he came out with what he called convection current theory. That there is a convective current. There is a convection loop below the surface, and that convection loop is of molten material, molten rock material, he called magma. He suggested that the magma flows in the form of cell. Like this way. The surface. He didn't explain much about it. He simply suggested that a rising column of magma may cause a result into breaking of Pangea. This theory is not mentioned in syllabus, but obviously we'll have to understand it, what is convectional cells taking place, because this has been used by seafloor spreading, Harry Hess, and it has also been used by plate tectonic theory. So he tried to explain, but he didn't have further explanation because again of the lack of information about the interior of the earth. Hence, this remained a simple theory, again not acceptable by many. So not much development thereafter took place, roughly around 1928-29. I don't remember exactly the year of this theory he propounded. Then there is a very good long lull period in this particular topic. Right, what happened in during and after Second World War, then again it restarted the discourse of continental drift theory, and that basically what led to seafloor spreading. There was a question that discussed the caustic development, which has led to the formation of seafloor spreading. So that is basically the historical perspective. The same question may be asked in about continental drift theory also. Discuss the developments which took place before the evolution of continental drift theory suggested by Wegener. So then you have every right to say talk about the Francis Bacon, the Antonio Snyder and all, and then the paleoclimatic studies of Wegener, actually till before the beginning of the continental drift theory. Right. So here the development which took place during the World War II, especially by the submariners. The army which used navy and submarines, they were the one who discovered several things, and thereafter studies were conducted by scientists to find out some things. So submarines basically discovered the features on the surface of the oceans. The first one is the existing belief about the flatness of ocean bottom. It revealed that the ocean bottom is as rugged as the continents and even more than that. They discovered various landforms like mid-oceanic ridges, trenches, seamounts, and other features. Later studies proved the existence of many unbelievable facts. Number one, the most important one is the age of the oceanic crust. Nowhere it was older than 135 million years. No, this is the discovery during Second World War, or which actually forced the Harry Hess or other scientists to think about the theory and that. Huh? 135 million years. Million years. The second one is very thin sedimentary deposition over the oceanic crust, where the thickness increased away from the ridge towards the trench. Third is age of the crust was also increasing from the ridge towards the crust. Sorry, towards the trench. Now, this was very perplexing for most of the people of that time. Why? Because everybody knew that the age of the earth was around 4.5 billion years old, and the oldest rock on the continental areas was 3.6 billion years old. Right? Now, how the oceanic crust is so young, just 135 million years old, the oldest part. Right? So that was very disturbing for most of the scientists of that time. How is it possible that oceanic crust is so young? And on top of that, these aberrations. First, the presence of the various types of landforms, which earlier was believed that the below the ocean, the surface must be very smooth and flat. But after the discovery, they realized that there are more number of landforms, and as far as the continents are concerned, almost equivalent, and even more number of landforms. So that needed a proper explanation. Right? That's what the Harry Hess was inspired, and he tried to explain again with the help of the convection current theory of Arthur Holmes. That's yes, sedimentary deposits also. Sedimentary deposits is basically a product of the continental areas, right? And now, if the continents are sending sediments, like winds are sending sediments, if the ocean is as old as the continent, then the thickness of the sediment must be higher. That means the sediments, whatever is thrown out or blowing from the continental areas, are disappearing somewhere. So where they are disappearing? That's first question. Like you can estimate very easily on daily basis, suppose roughly a part of ocean is receiving, say let's say a 0.01 millimeter of sediments every day. That means you can easily estimate over the period of time, if the earth is that much old, the thickness of the sediment should be this. But they found the thickness of sediment very, very less than the expected thickness of sediments. No, continental thickness is different. The sediments over the continent is byproduct of the external forces, but that external forces is not expected on the ocean bottom. That's a different issue. But wind is blowing over the continents, it is sending sediments from the continents in the oceanic areas. Let's say suppose coastal areas 10 kilometers away from this particular coast. And today you can see that in this month, 1 centimeter thick sediments have been deposited from the continent in that ocean area. Let's say suppose whatever is blown to the ocean water, that will sink down and then it will get deposited. So every month that must be added. So if the earth or the crust is as old as the continents, then the thickness of sediment must be very high, and but that high thick sediments which is expected is nowhere near to the exact amount of sediments present on the ocean floor. That means whatever the sediments are brought from the continents, they are being displaced somewhere else. So that was also a question mark, that where did these sediments gone. Second thing is the thickness of the sediment were decreasing from the mid-oceanic ridge towards the trenches. That means, and the further supplemented by the fact that the age of crust was youngest near the mid-oceanic ridge and oldest near the trench. Right. So that's how later on Hairy Hesse came with the idea which is called, tried to explain that the features of the oceanic crust is a product of internal convection as suggested by Arthur Holmes. He took the help of convection current theory of Arthur Holmes and tried to explain these features and other informations which were gathered during that period.
How do we calculate the age of the
Age of the
rocks?
is very easy. There are several methods: carbon dating method, magnetic methods, and all. There are several methods through which age of the rock can be calculated.
Technology was available.
Huh?
So technology was available.
Yes, that was available at that time. Carbon dating is a very old this thing method to check the age of the rock. The carbon decay method, you might have read it. That carbon decay 50% takes place in this particular period. So if the carbon content in a particular rock is that much amount which is expected, then let's say 1/4, that means age can be calculated roughly. That's not exactly it, right?
So then how would they able to calculate the thickness of the crust at that time?
Thickness of the crust, not thickness of the sediment, not thickness of the crust. Thickness of the sediments can be easily calculated. You dip something, you calculate this. Obviously, before the under the sedimentary rocks, there must be oceanic crust which is volcanic in origin. So sediments can be easily measured. उसमें जाना नहीं है वैसे, वो सब रिसर्च नहीं करना है. वो सब करने लगे फिर तो पूरा जियोलॉजी पढ़नी पड़ेगी फिर उसने. ठीक है. Arthur Holmes, right? He suggested that, he propounded the idea which is popularly known as seafloor spreading. According to him, or according to Hairy Hesse, the magma formed below the earth crust rises under the influence of the density differentiation. This rising column breaks the crust and comes out to form, comes out and deposits to form the mid-oceanic ridge. Density differentiation. This rising column breaks the crust and comes out and deposits to form the mid-oceanic ridge. From here, the sea floor spreads away along both the sides of the ridge. That's what we call sea floor spreading we further suggested that the newly created oceanic crust along the ridge moves towards the trench and get destroyed into it. The trench is the site of descending column of magma, which allows the crust to sink along it. Yeah, completely, not a bit of it. Now, what he is suggesting is, just like he took the help of Arthur Holmes' convection current theory, and he suggested that when the magma is coming, initially it may not be able to tear the crust apart, right? So, but only hitting this part. So, before actually it has come out, it will spread horizontally in this, and then it will have both descending and rising column. Along the rising column, after a continuous effort, that magma will break the crust and will come out, right? So, the moment it has come out, this is the set of new rocks deposited, right? When these new rocks are deposited, they will gradually spread on both the sides, right? Continuous spread, and they will sink along the descending column of magma, and that sinking part will produce trench. That is the deepest part of the ocean, and along this newly crust created, after point of that, this will be here, this will be here, the same part ultimately will get destroyed. Now, when you explain that the new crust is being created, that means the size of the earth must continuously increase. If you are creating new crust and it is spreading, that means the size must increase. To overcome that, there has to be compensation for whatever new size has been increased and new part has been added, that must be destroyed somewhere to make the size constant. To explain that, he suggested that when the rising column of magma creates new crust, this spreads in both the direction and ultimately and gradually get destroyed into the trench. Yeah, whatever it is, we are just talking about what he suggested, right? So here he is suggesting that that's why the age of the crust. Now in one go he has explained several things. Right? He has explained the presence of mid-oceanic ridges and the formation of it also. He has explained why the crust is youngest here and oldest here, yet it is not very old, because all the older crusts are getting destroyed in the mantle. Getting my point? So whatever young, old, it becomes old and old and old. Ultimately it becomes, after a point of time, it goes inside the mantle. So the age of the crust he has explained. That mystery has been solved according to him. That the crust are, oceanic crust are youngest. You can now write down the way he explained. In this way, he explains most of the discoveries of the newly discovered features and informations through his theory. For example, number 1, he explains the youthful age of the oceans, the oceanic crust. Right? New crust is being created along the ridge, and the oldest part is being destroyed along the trenches. Second part, the sedimentary or the thickness of the sedimentary rocks are less because of the lesser age of the crust. Besides, the age increases towards the trench, hence the thickness of the sedimentary rocks as well. That he has not explained. That is explained by plate tectonic theory. Right? He simply suggests that along the descending column of magma, the crust will sink. So that is very scientifically explained by plate tectonic. That's why we are not talking about the formation of trench here, because he is simply trying to explain the outcome of that discoveries and invention at that time. Yeah.
So overall, theories in geography
Mm.
are very well connected.
Yes.
I mean, so when we write answer,
Mm.
there has to be a mention, of the topic, because it's all interconnected.
Not all. Like for example, this is basically, these all are historical basis for the development of plate tectonic theory. So that's what, like this question has not been asked. I have just made it in my geography test paper, that the evolution of plate tectonic theory has a long history behind it. Elaborate. Then in that you have to start from the Francis Bacon and the St. Antonio Snyder, then F.B. Taylor, which is not mentioned in the syllabus. But we have deliberately discussed it because that question is not far away from the examiner's mind also. Then continental drift theory, then seafloor spreading. Again, seafloor spreading is not clearly mentioned in the syllabus. Then magnetic anomaly. Now we are going to discuss. Then you have plate tectonics. So all these are basically the ladder stage of the plate tectonic theory, which ultimately culminated into plate tectonic theory. So that's why I am talking about all in an integrated one.
The mechanical also is static position, or it varies?
That has not, it has not been talked about. What we are right now talking about are the theories. What Harry has suggested. What were the discoveries? We are talking about that. What is the actuality or the actual state of that convection current or the plate or the continent or the ocean is explained by plate tectonic theory. So then when we are talking about plate tectonic theory, then we will discuss all these things. That's how plate tectonic theory is the culmination of all. And the present belief about the landforms and various features are the aspects happening inside the crust is in accordance with the plate tectonic theory. That's how it is accepted in the present day. Right. Hope we are understanding this part. So the seafloor spreading or Harry Hess must be credited for extension of the movement of continents or the crust beyond the continent. Right? Wegener has confined his theory to the continental areas. Harry has brought it to the oceanic areas. What Wegener has suggested is that the continents are drifting. What Hess is suggesting that oceanic floor is spreading. Right? Again, not many scientists were ready to believe at that time that how is it possible that oceanic crusts are spreading, and then if it's spreading and why it is destroying. So several questions were raised. Right, that it is again just like continental drift theory and it will remain an aberration. The first support to seafloor spreading came in the form of what we call magnetic anomaly, right, presented by Vine and Matthew. Now to understand magnetic anomaly, first we have to understand the crustal part. What Hess is suggesting? That new crust is being created and is spreading in both the sides. Right? So how can you prove that it is actually happening? So that has been proven by Vine and Matthew, and which is popularly known as magnetic anomaly.
This didn't explain about the continental crust.
He doesn't talk about continental drift. Harry Hess does not talk about continent. The best part of plate tectonic theory is that they have worked least and they are the most popular. What plate tectonic theory has done? Just joined both these. He suggested that W.J. Morgan is the main architect. There are several scientists behind that, but the name is credited is W.J. Morgan. He suggests that neither continents are drifting. It is not oceanic floor which is spreading, rather it is plates which are moving. And the plates may be continental, that is continental drift theory. The plates may be oceanic, that is seafloor spreading, or may be oceano-continental. Right? But the mechanism, that's why plate tectonic theory is an idea which incorporates the entire theory behind it. That also may be a question. The statement can be framed that plate tectonic theory is an idea which incorporates the entire theory before it. Discuss. So the answer pattern will be different when the question or statement is framed like this. So that is magnetic anomaly, or that's what you call paleomagnetism. Given the credit given to Vine and Matthew. The detail of it, we'll talk about the geomagnetism. A part of it is geomagnetism. Paleomagnetism, the study of the past characteristics of magnetism of the earth. Magnetic anomaly, I hope we understand, right? The term anomaly, deviation from the normal. It is associated with the reversal of the magnetic poles periodically, or periodic reversal of the magnetic poles. That's also called magnetic reversal, or it is also called polar wandering. That is, magnetic poles wander, move, shifts, change their place. That means in one point of time this is north and this is south, the same will be reversed. This will become south and this will become north. That is magnetic reversal. इसमें ज़्यादा दिमाग लगाना नहीं, because अभी तक भी we are not able to decipher why does it happen. That may happen in 300, 400 years, even more than that, maybe million of years. It take 1 million years to reverse the change. That is, change happens. The magnetic north becomes magnetic south, and magnetic south becomes magnetic north. Right? That is what you call magnetic reversal. Why? We are least bothered about it. Because जब साइंटिस्ट ही नहीं जानते तो हमें पढ़ने की क्या जरूरत है. और अच्छी बात है कि नहीं जानते, वरना एक और एडिशन इन्फॉर्मेशन हो जाता है आप लोगों को. ठीक है. अब ये एक चीज है कि हाउ इट हैज हेल्प दी टू प्रूव दी सी फ्लोर स्प्रेडिंग. What Matthew has suggested, that each rock contains elements with magnetic property. Right? Iron and all. Right? They attain the magnetic declination or magnetic direction at the time of their origin according to the direction of that time. That time, each period of similar magnetic direction produces a strip of land which reflects similar direction within but different direction from the nearby strip. he found that the strip away from the MOR, mid-oceanic ridge, is alternatively similar and different from the nearby strip, thus proving the sea floor spreading theory by Hess. Just a second. Let's imagine this as a part of mid-oceanic ridge, right? What Hess has suggested that the spreading is from both the sides. Let's say, suppose this strip is formed during a period, so the same strip would be formed during the same period, this side also, right? And period of similar magnetic direction. The next strip must have been formed in a different direction. And this is how the strip would have been alternatively arranged from the mid-oceanic ridge till the trenches. That's what Harry has suggested. Now, if the magnetic reversal is showing a direction, let's suppose at the time when this strip was being formed, north is north and south is south. But at the time when this strip is formed, north was south and south was north. So this same declination must be here and this declination must be here to prove that sea floor is spreading. थोड़ा उसको जगाओ तो बहुत मुस्कुरा रहे भाई साहब. हाँ, मैसेज ही ऐसे है ना, तो थोड़ा सा काम भी कर लो. हाँ, या कम.
Okay, now if you say the magnetic poles are getting reversed, so then this is explained. What if the continents or the plates are moving, and if the direction, like the southern continent is moving, if you say the Indian subcontinent.
No, forget about that. Plate tectonic is altogether different. This theory or this explanation was basically to prove that sea floor is spreading.
Now if the landform is moving, the direction of the landform itself changes. So how can I
So
say
even in that case, no, that's not contradicting. What you are suggesting that suppose north is north and south is south. I think what I can perceive from your question that if the direction is in this, it is fine. What if the direction is like this? That's what you are asking, I hope. So if the direction is like this, each strip must be showing north-south this way. That's it. If the direction of the ridge is similar to the direction of the magnetic poles, then the north should be north and south should be south in a vertical manner. But if the direction of the ridge is perpendicular to the direction of the magnetic poles, what will happen? That's what your question? नहीं, तो क्या है question? Question explain.
if the continents are moving, like if Australia and Africa and India is moving,
It's fine.
if it's the west, like it's drifting towards the west as well as towards the north, and in that case, in that period, if there's a reversal,
Hmm.
So the magnetic strips would have been in a different alignment.
Yes, that's true. In the alignment of the north-south only.
Yeah, but south would be up and the north would be down.
That's true.
So in that case, if you're saying, okay,
That's what the strip is like this. So north will be north, south will be south in a vertical manner. If the strip is like this, right? So this strip will be showing north here and south here. So this direction rather than this direction. That's it. The difference will be only the.
Is it the main cause of spreading that same poles are like going apart? That's why he demarcated as the same poles, like same alignation at the ridge. That's why they are spreading apart.
No, why it was spreading was explained by Harry Hess. It is actually spreading has been confirmed by Wine and Matthew. There is a difference.
What is the role of magnetization here?
It has confirmed that yes, seafloor is spreading.
How is it?
So these are the layers, right? These are the north-south, like it's not like this, it's not like this, no, at the surface. Then how it confirms the spreading?
Okay. For it confirms the spreading in this manner. That one first thing is that magnetic reversal is a truth was acceptable at that time. That magnetic pole reverses its direction. So the question arises that was the question. If the magnetic pole reverses, then that must be reflected in the oceanic spreading. For example, this is the ridge, and these two strips have been formed in the present north and south direction. Then the rocks reflecting magnetic characteristics within this strip should reflect north and south. Let's say suppose we have a magnetic compass, right? If you jolt the magnetic compass, shake it, and then leave it, so it will attain north and north south. The same magnetic compass, if would have been used, let's say 2000 years before, where the magnetic direction is different, what will be the direction of that compass? Opposite, right? North will be towards south and south will be towards north. The same is expected in the magnetic strip. If you are saying, for example, I am challenging you, you are Harry Hess. I am challenging you that, okay, fine, if it is so, then the magnetic north and south must have a different alignation here. And that alignment must be reflected in each strip, and each strip which is adjacent to the mid-oceanic ridge must reflect similar alignment. Okay, from the ridge, the magma is spreading in both the direction. So if this strip A and strip A, B this side, is of similar time duration, then the magnetic declination must be similar. If away from it, suppose this strip is reflecting reverse direction, so this strip should also reflect reverse direction. Only then we will believe that yes, it is spreading.
It's just showing a symmetric spread.
Yes.
Like
Symmetric spread, symmetric strip, and symmetric magnetic declination as
but there is no relation between magma and the reversal of magnetism.
well. Why?
How comes that?
Magnetism, how is it means that the magnetic inclination is dependent on the reversal of the north-south pole.
No. It is not dependent on north-south shore.
Then
But
how is the strips like this?
actually, whenever the rocks are formed, magma is what? Molten rock material. When it cools and solidifies, it becomes rock. Right? So when it is cooling and solidifying, it is young rock. And when it actually becomes rock, it attains the magnetic property of its time. Right? Suppose nowadays, whatever rocks are being formed on the ocean surface or the continents, the elements of rock or the minerals present in the rock which are magnetic characteristics. Not all the minerals have magnetic properties. So they will reflect a direction of ye north hai, ye south hai. Or just imagine that a compass is kept in every strip formed during the same time period. So let's say in the last year, suppose every year it is changing. So in 2016, whatever strip or this strip is being formed away from the ridge. So this is showing north, this is showing south. So this must also show north and this must also show south. If I am planting third finger here in this manner, so if it is showing south, this should also show south. Because rocks formed previous year, rocks which were formed previous year when the magnetic direction was different. So the newly formed rocks in 2015 must reflect the direction of that time. So each alternative strip must not only show similarity with the adjacent strip of their counterpart, but also be dissimilar from the nearby strip.
So then the direction of the north and south will be continuously changing.
No. And so there should be continuous strip from the mid-oceanic ridge to the trench, and each strip, alternative strip, should be symmetrical to the counterpart and different from the nearby.
So right now you're just talking about the oceanic things,
Hmm.
no other.
No, we are not talking about any other. Is answered.
Yeah.
Okay. That's how Vine and Matthew helped strengthen the belief of the seafloor is spreading and convince the people or the scientists of that time, yes, seafloor is spreading. And that forms again one of the most important basis of plate tectonic theory. Till here we're clear? Sure? Plate tectonic theory. 1965 it came. It's the most generally the name given is W. J. Morgan. 1965. The most acceptable, has scientific basis and explanation for almost all the features on the surface of the earth. First, it suggests that Earth's lithosphere is divided into several plates. Right? It identifies 6 major and more than 20 minor plates. It suggests that plates are moving independently and with the mechanism of the plate movement variety of landforms are produced. Now, first the basics of it. We'll discuss 3 things. First is, what do we mean by plate? Second is, how the plates are formed. Third is, what are the forces which cause the movement of the plates. why these plates are moving. There are 3 questions which we'll try to answer. अभी आते हैं एक एक करके. Right? Why do these? What do we mean by plate? So plate is basically a 3-dimensional figure. Entity or part of lithosphere that is roughly 100 kilometers thick. Right? Which has margin and boundary. The marginal part or the side walls of the plate is called plate margin. Whereas the base or the surface trace of motion is called plate boundary. Right? Hope we understand. What is the margin? Let's say suppose this is a plate. So what is the marginal part? All the side walls is margin. Right? This is surface trace of motion or base of the plate is called boundary. Getting that point? Right? So when we say divergent boundary, that means this is diverging. When we say margin, constructive, destructive margin, so what is happening to the side walls and how the base is behaving. This, when we talk about the 3 types of movement, you always read that convergent boundary or destructive margin. So when there is a convergent boundary, so the boundary is converging, that means base is converging, coming towards each other, and the margin will experience collision, so destruction. When we say divergent boundary, so boundary is moving away from each other and the magma is coming from below and it is getting deposited on the side walls, so constructive margin, divergent boundary. Hope we are getting that. नहीं, मुझे भी नहीं समझ में आया, समझते हैं, don't worry. This is clear. What is 3-dimensional part? Hope it is clear. नहीं? Now how the plates are formed. So first, it has also taken the help of convection current theory of Arthur Holm, but also but a bit different. Right? He suggests that plates are cracked or develop fissure along the line of the rising column of magma. Right? This rising column results into dooming of the plate develop cracks on the surface outline its boundary and subside to form a rift valley.
There's upturning or downing?
Where? Updoming.
Dooming.
Doming. Updoming of the part or the plate, develop cracks on the surface, outlines its boundary and subside to form rift valley. The push effect from here results gradually forms or delineate the outer boundary of the plate and gradually become independent from the rest part of the lithosphere.
So if they create a bulge first, then they will be cracked.
Imagine I am applying a force here, right? So what will happen? First, before it breaks, a crack will be developed here, right? Before the development of crack, it will be pushed upward, bulging. That is updoming. So what happens? And here is a very single line I am talking about. Now imagine the magma is coming in the whole glass, and this glass has a continuous ceiling throughout. So when the magma is coming from this wall till this wall, so it will result into upliftment of the entire area. So first the area will be slightly updomed here, so that the outer boundary is being delineated now. That plate is going to be broken. So it is pushing them upward. So initially heating and all upliftment will result into pushing. Then outer boundary, then cracks will be developed. And the crack will develop when the outer boundary is delineated, that will subside. And that's how first part of the, or first phase of the plate formation is being completed. Now when the magma comes upward, it keeps on pushing it. Now look at here, only this part has been developed a crack, right? Rest is perfectly attached. When this magma is pushing this apart, just imagine that there is no further crack. But if you keep on pushing from that wall to this wall, so what will happen? There will be a crack developed in that direction also. That's how gradually that side walls will be generated because of the push of this. And a plate will be singly created or single-handedly created from the mid-oceanic ridge part. That's how the ridge will be developed.
These are the cracks which define the margin of that plate.
Yes. The outer boundary of the plate will be delineated. Let's suppose in this pen itself, if I am applying force from here till here. So it is a vertical, only vertical force. It has no attachment with the rest of the body. It's single, open air. So it can break very easily. Now imagine I am trying to break this dais on the middle of it. So on the middle of it, imagine the magma is coming. So it has created a fissure from here till here, but this part is also having rocks or continental area. This part is also having. Now the magma is coming and it is trying to push up till here only. And this dais is much bigger than what is visible right now. So it is trying to push it. Suppose only this part is being pushed, right? So this part will not be easily delineated, basically because this is attached with the rest of the body. But here you have good amount of push. So the continuous push, that's why it's a million years phenomena. So when continuously being pushed, just take one side. So it is being pushed very heavily, gradually, continuously. So what will happen? Along this side, first the cracks or side walls will be delineated. And after a point of time, this entirely is delineated. Then imagine the magma is flowing from below also. So a single plate will be created. Right? And thus being pushed, and then somewhere it will be pulled as well. Clear? Sure. चलो मुझे भी समझ में आ गया, पहले मुझे भी समझ में नहीं आ रहा था. Now third part.
Sir, different plates in the world. That's why if it is a level of Mid-Ocean in Atlantic Ocean, yes, shape, and then the different plates. Then is it so that they are moving apart because of like if particular plate is moving, not they're not a single, like a single plate nahi hai, for instance, plates are divided. That's why the like temporal pressure, जो एक जगह pressure पड़ रहा है extra, जब plates generate कर रहे हो, like the wave plates are generated. Is this a reason for different plates in the world?
Yes, wherever the fissure eruption is taking place, there you will have the delineation part or the beginning of the formation of plate. So fissure eruption is basically radiogenic heat, the basics of volcanism, and the radiogenic heat is creating fissures, and that fissure which is being radiated, the landforms will be formed. So magma will come where the energy is there. Everywhere there is no radioactive minerals or no asthenosphere having that deposition. So wherever in the pockets the magma is being created, that area will be more suitable for the formation of a plate or beginning of a plate movement.
Is it the number of plates can increase eventually?
Yes. That's why it is a mystery. That's why first of the criticism of plate tectonic theory is that we don't know exactly that how many number of plates are there. Yes.
Is there a possibility it can decrease?
It can? Yes. It can decrease with the convergence. The plate has already decreased. Earlier Indian plate was there. The moment Indian plate is colliding against the Eurasian plate, once it is still demarcated, once it gets established, now there is no movement, so the whole plate will be a single plate.
Just like,
So if these more plates are being created,
Welding, exactly.
so more plates are being created as well.
Maybe, like for example, East African Rift Valley, have you heard the name? So that is a believed site for the divergence, present day divergence which is happening. But the divergence is not complete. It is still in the form of series of Rift Valley which is not properly connected with each other.
So in a simple way, if I have to explain, if I take a chocolate bar and try to break the chocolate bar from between, and the cracks and the pieces that the bar develops and the entire bar falls apart. It's how I can explain it.
No, I'll explain only when you feed me a chocolate. Yeah, that's true. But remember that chocolate is a single piece which doesn't have connection with the rest of the thing. And a plate is a part of the spherical earth. So when a part is being cracked, imagine earth, just let's say suppose, imagine any of the part which is being cracked here, right? Now just imagine that it is intact. So it is being cracked here. This part only is being cracked. So what will happen? Rest is attached. This is also attached. This is also attached. When it starts pushing, so it will delineate according to that. It not necessarily that delineating this way. In the process of pushing, this might also gradually develop without having magma also.
Raw egg is a better
Enjoy it.
raw egg is a better example.
Huh?
Raw egg is a better example.
Raw egg is a structural example. Like when we discuss about the structure of the earth, the egg is a very good example of a structure of the earth. Now, if you want to develop cracks on the egg, right? So, egg may have development crack, still the filament will be attached. So, if it is a single piece, then that is a plate. That independence of the single plate or the formation of the single plate is associated with fundamentally, not only, but fundamentally what is happening along the ridge or rising column of magma. Now, we are looking it at a single entity, but what is happening at the convergence is also an important part. So, delineation is a combined effect of the movement of plate mechanism. How does the plate move and why the plate should move? Right? If you look at that aspect, then you can understand the formation of plate itself very easily. So, why the plate should move? Now, look at here, each of the plate has a divergence and a convergence as well. So, when the plate is formed, first thing is that when the plate is being formed along the mid-oceanic ridges, updoming will take place, right? So, you start from there, that is what you call how the plate will be formed. It starts with, in the bookish language, what you call a ridge push, slab pull. Third is mental plumb, that's density differentiation. And gravity variation. Or temperature variation, those all of are interlinked. When we say ridge push, this is also called mental plumb. Mental plumb. Mental plumb means the rising column of magma, right? Imagine this is a piece of lithosphere which is being hit by the rising column of magma. Right? न्यूयॉर्क से आए हो? हैं? न्यूयॉर्क से आए हो? फिर इतना डरते क्यों? You are behaving like the woman. Oh my God, cockroach. नहीं? Enjoy it?
Now we're taking hands, sir.
ये hands मतलब इतना ज़्यादा enjoy it. भगवान ने क्या इसको? क्लास खत्म होने के बाद. So the moment this is there, look at here, rising column of magma means high temperature, right? High temperature. Now initially the updoming will take place. This part will be updomed. Now the moment updoming is taking place, first thing is that, now look at this newly created plate. In a nutshell, it's something like that. Not maybe that visible, but to understand this. Right? The entire portion will have high temperature. Relatively, the marginal part or the other side of the plate, low temperature. High temperature means lighter, heavier, Any doubt? So density differentiation, and because of density differentiation the slope is being created, right? This has resulted into slope means gravity variation. Hopefully we can understand, right? Now third stage, it is being broken. So actually now the plate is something like this. Any doubt? Right? So slope is being created. Now when the magma is coming, it will push away. That's what you call ridge push. When here it is descending into what we call trench, this is what we call slab pull. Clear? No? Sure, no? This is what we call mantle plumb.
So it is a force slab pull.
Slab pull.
So how?
Like just imagine the entire plate is attached. So if this is moving down, so in the process rest of the plate will also be pulled down.
This side is heavier also.
Yes. Heavier is generating basically the gravity variation, the slope. Slab pull is altogether a different thing. So it's not only any single factor, but movement of plate is a result of the multiple factor, which includes all these. And if suppose you are supposed to explain it, explain in this manner. What is the mantle plumb? Then what will be the result of mantle plumb in the case of movement of plates? First, it will increase the temperature, will result into updoming. Then updoming after being broken, ridge push. Then updoming results into slope creation, gravity variation, resulting into an automatic smooth, at least condition for the smooth slow movement. And now the mantle plumb is providing a slippery surface. What is this continental drift theory has suggested that Sial is floating over Sima. What is happening? Lithosphere is moving over asthenosphere. Asthenosphere and the horizontal column of magma is providing the base for the smooth movement of the plate. Clear hai? Sure? Now the types of the movement. Types of the plate movement. divergent boundary, or the same is constructive margin. The second is convergent boundary or destructive margin. And third is the conservative boundary or passive margin. Example of first is you break it here when the plate is moving in these two directions, divergent boundary. The same is here when these two plates are moving towards each other, convergent boundary. And the example of third is this plate is moving independently and this boundary is conservative. This is also called transform fault. That means this is called transform fault. The term plate was first used by Tuzo-Wilson, after which you have the name called Wilson cycle. That Pangea formation, disintegration and again formation is a continuous phenomenon.
Basically, the third one is the displacement of one of the
No. Let's say suppose this plate is moving and this is the part. Now if it is moving like this, other plate is coming, this is convergent. Moving from away, divergent. Now what is happening here in this? Nothing. Neither magma is coming. What is coming here in the divergent boundary? Neither destruction or collision is taking place. What is happening here? So what is happening here? Here. This is a static part of the land and the plate is moving. For the independent movement of plate, this plate must be detached from here. And that detachment is called conservative boundary.
one is starting and the other is moving.
Huh?
One is starting and another is
Moving. This also may move. This may also be moving, but they are moving independently, and the crack which is providing them a smooth movement without actually either involved in collision in the form of convergent or divergent, that is conservative.
With this course is going to be okay.
Yes. कभी कभी अटक जाएगा ना, because आरी से कटा हुआ तो है नहीं. But if some part is projected of this plate which is moving like this and this gets stuck somewhere, so it has to break in the process of that displacement of rock, earthquakes. Right? Like San Andreas fault is a very famous and most widely studied transform fault or the conservative boundary along the California coast. So that is the best example of conservative boundary and experiences very regular earthquakes.
Sir, all the three processes are always happening if there is a plate movement.
Yes, has to happen. Somewhere there is divergence, somewhere there is convergence.
Is there any prominence of any movement, like divergent boundaries move, or convergent there is move, displacement of convergent boundary?
That's the criticism of the plate tectonic theory. Like if the divergence is there, convergence is there, Earth's size is not increasing, then there must be uniform. The rate of divergence must be uniform, similar to rate of convergence, but that's not there. Very often it has been found that they are different.
Has to be compensated for.
Has to be compensated. Otherwise, the Earth size should increase. There should be increase in Earth size, circumference, but that's not also taking place. ओके, आज के लिए काफ़ी इतना, कल विल कंटिन्यू दिस वे. थैंक यू एंड टेक केयर.